Hi, I'm Bob Pryor, and I'm talking to you today about trigonometric equation strategies. That is, strategies for solving trig equations. Sometimes a trig equation is not yet ready to be solved, and this can occur when the equation contains two or more different trig functions, or that there is more than one argument present, such as sine of 2x and sine of x. In either case, we prepare the equation for solving by using one or more trig identities to alter the look of the equation. Let's consider this example solving for x when x is between 0 and 2 pi. The equation is tangent x minus 3 cotangent x equals 0. And you see we have two different functions in the equation. What we're going to do is change them to the same function by making cotangent of x into 1 over tangent x. Of course, that's equal to 0. And to clear the fraction that we now have, we're going to multiply each side by tangent x. On the left, we're going to distribute tangent x to each term. Tangent x times tangent x is tangent squared x. And tangent x times the next term, we get just 3. Tangent squared x minus 3 equals 0. Add 3 to each side. Tangent squared x equals 3. And then we take the square root of each side. So tangent x equals square root of 3. But don't forget the plus or minus. So let's now find the value of x, where tangent x equals plus or minus radical 3. Theta hat is 60 degrees for square root of 3. And that occurs, of course, at also pi over 3 for radian values. But because tangent x is plus or minus square root of 3, we actually use all four quadrants. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And so we write our solution set, x equals each of those values. Right, let's see what's next. Again, we're going to solve for x between 0 and 2 pi. This time, we've got a cosine and a sine in the same equation, and the cosine is being squared. Well, the only identity that we can possibly use in this case is the fact that cosine squared is equal to 1 minus sine squared. And that's good because it will allow us to put the entire equation in terms of sine. 4 times 1 minus sine squared x. And then minus the 4 sine x and minus 5 equal to 0. We'll distribute 4 minus 4 sine squared x, minus the 4 sine x that's already there, and minus 5 equal to 0. Notice that we have a constant 4 and a negative 5. Those are like terms, and they'll combine. So we get negative 4 sine squared x minus 4 sine x, and they combine to negative 1. To make the first term positive, we're going to multiply each side by negative 1. It's easier to work with when the first term is positive. 4 sine squared x plus 4 sine x plus 1 equal to 0. Well, we're going to have to do some factoring here, so let's let w equal sine of x. The left side expression becomes 4w squared plus 4w plus 1. And this factors into 2w plus 1 times 2w plus 1. You may use any factoring technique that gets you to that answer. But this is nice. It equals 2w plus 1 squared. So what we're going to do is rewrite the left side as quantity 2 sine x plus 1 squared. And it's equal to 0. Then we'll take the square root of each side. 2 sine x plus 1 equals 0. We don't need to do plus or minus 0 here. Subtract 1, divide by 2. Sine of x is negative 1/2. In the unit circle, sine is negative in quadrants 3 and 4, and sine is 1/2 at 30 degrees. So theta hat is 30 degrees, or pi over 6. In quadrants 3 and 4, that's 7 pi over 6, and 11 pi over 6. Those are our solutions. 7 pi over 6, comma, 11 pi over 6. Okay, this time we're going to solve for theta. Notice it has sine of 2 theta on the left and cosine of theta on the right. We've got different arguments, a 2 theta and a theta, and we're going to have to get them to be the same single argument of theta. And we're going to use the identity sine of 2 theta is equal to 2 times sine theta times cosine theta. So on the left side, we'll replace sine of 2 theta with that identity. 2 sine theta cosine theta equals square root of 2 cosine theta. At this point, we're going to subtract square root of 2 times the cosine theta so that it shows up on the left side, and we get 0 on the right side. Now notice that we have sine theta times cosine theta, and also root 2 times cosine theta. Cosine theta is actually a common factor, so we're going to factor out cosine theta. And as we do, we get 2 sine theta minus square root of 2. Still, of course, equal to 0, and that means we'll set each factor equal to 0. Cosine theta equals 0, or 2 sine theta minus radical 2 equals 0. The second equation gives us sine theta equals positive square root of 2 over 2. Going to the unit circle, cosine of theta is 0 along the y-axis at 90 degrees and 270 degrees. Sine of theta is positive square root of 2 over 2 at 45 degrees and 135 degrees. So theta equals all 4 of those values. Now I want to present this caution to you. What we see here is the second step of the previous example, where we had 2 sine theta times cosine theta equals square root of 2 cosine theta. And the question arises, what happens if we divide by cosine theta? Well, let's check it out. Divide each side by cosine theta, and they cancel on each side. We're left with just 2 sine theta equals square root of 2. Dividing by 2, sine theta equals square root of 2 over 2. And that gives us values of 45 degrees and 135 degrees. The question is, what happened to the other 2 solutions we got when we did example D? What happened to 90 and the 270? Well, it was dividing by cosine theta that actually created a problem, because we might be dividing by 0. The point is, we can't divide out a function. We can divide by a number like 2, but we can't divide by a function when solving an equation. In the last example, we used a double angle identity because we had 2 different arguments. But we can also use a double angle identity even when no other argument is present. In this example, we're going to solve for all possible degree values of theta. Sine of 2 theta equals 0. The double angle identity says 2 sine theta cosine theta equals 0. And so we have 2 different factors that could be 0, either sine of theta equals 0 or cosine theta equals 0. In the unit circle, sine of theta is 0 on the x-axis, and cosine of theta is 0 on the y-axis. So we have all of our axial values, 0 degrees, 90 degrees, 180, and 270 degrees. Because we're finding all possible degree values, we can add 360 degrees K to each of these. I'm going to call this option 1, where we have all 4 angles plus 360 degrees K. Option 2, though, is where we say, look, each of them is 90 degrees apart, so why don't we start at 90 degrees and add 90 degrees K, and that will generate all of the solutions. A third option is actually to start at 0 and add 90 degrees K, or I'd just say theta equals 90 degrees K. K is an element of Z. Any of these options is fine. In this next example, again we have two different arguments, 2 theta and theta. This time it's cosine 2 theta. Well, here are the double angle identities for cosine. One function within our equation is sine theta. So let's use the double angle identity that's 1 minus 2 sine squared theta. So cosine 2 theta is replaced by 1 minus 2 sine squared theta, and then we have plus 3 sine theta minus 2 equals 0. Notice we now have two constants. We have a positive 1 and a negative 2, and they will combine to a single term. We're going to multiply each side by negative 1 to make the first term positive. 2 sine squared theta minus 3 sine theta plus 1 equals 0. We'll need to factor that, so let's let w equal sine theta. This becomes 2w squared minus 3w plus 1, and use whatever factoring technique you know best to factor this into 2w minus 1 times w minus 1. But that becomes 2 sine theta minus 1 times sine theta minus 1 equals 0. So we can set each factor equal to 0. In the first equation, we'll add 1 and divide by 2. Sine theta equals 1/2. In the second equation, we'll add 1. Sine theta equals 1. Referring to our unit circle, sine theta is 1/2 at 30 degrees and 150 degrees. Sine of theta is equal to 1 at 90 degrees. We have three solutions. Theta equals 30 degrees, 150 degrees, 90 degrees. These solutions could be written in any order, but it's nice to pair them up as we see here, 30 and 150. Okay, we're going to do an algebra example about squaring an equation. We're not squaring the whole equation, we're just squaring each side of the equation. And we do so because we have a square root. And you can see that when we square each side, we get no more square roots. We have x plus 3 equals x squared plus 2x plus 1. We'll subtract x and 3 from each side, giving us 0 equals x squared plus x minus 2. The right side factors into x plus 2 times x minus 1, and we set each of those factors equal to 0. We get two answers, x equals negative 2 and 1. Well, we're going to go ahead and verify that each of these is indeed a solution, but we're talking about a solution in the original equation. So when x is equal to 1, we put 1 into the original equation with the square root 1 plus 3, and we want to know, does that equal 1 plus 1? Well, that's the square root of 4 equals 2, at least we hope it is. 2 equals 2, yeah, that's true. Let's now put in x equals negative 2. Square root of negative 2 plus 3 equals, or does it, negative 2 plus 1. That's the square root of 1 equals, question mark, negative 1. Oh, well actually, no, they're not equal. It's a good thing we checked. Because what we have here is one value of x that makes it true, that's a solution, and another value of x that makes it false. So it's not a solution. So why does that happen? Well, we have a name for this x equals negative 2. It's called an extraneous solution. It's extra. And it comes from the modified equation. It comes from after we square each side. So squaring each side introduces sometimes these extraneous solutions. Well, let's get back to trigonometry. Here we have an equation of cosine x minus sine x equals 1. Notice, though, that neither function is squared, so we cannot use a Pythagorean identity to get it down to just one function. So what we're going to do is introduce a squared function by squaring each side. First, though, I'm going to get the functions cosine and sine on the opposite sides of the equal sign by adding sine x. That gives us cosine x equals 1 plus sine x. And here, we're going to square each side. Cosine squared x equals 1 plus 2 sine x plus sine squared x. Now we have two different functions, sine and cosine, but we have cosine being squared. So we can use the Pythagorean identity 1 minus sine squared x. And that then is equal to 1 plus 2 sine x plus sine squared x. We'll make it 0 on the left side by adding negative 1 to each side and by adding sine squared x to each side. What we get out of this is 0 equals 2 sine x plus 2 sine squared x. And on the right side, we can factor out a 2 and a sine x. And we're left with 1 plus sine x. So that means that each of those factors could equal 0. 2 sine x equals 0, or 1 plus sine x equals 0. In the first, we'll divide by 2, so sine of x equals 0. In the second equation, we'll subtract 1. Sine x equals negative 1. So sine of x equals 0 on the x-axis, and sine x equals negative 1 at 270 degrees. But we're working in radians right now, so that means 0, pi, and 3 pi over 2. But because we squared each side, we need to check each of these answers into the original equation, the x equals 0, pi, and 3 pi over 2. So when x is equal to 0, we get cosine 0 minus sine 0 equals 1. Or does it? That's the question. Cosine 0 is 1, and sine of 0 is 0. 1 minus 0 equals 0. Yeah, that's true. Good. We have one solution. Let's now try x equals pi. Cosine pi minus sine pi equals 1. Again, question mark. Cosine pi is negative 1. Sine pi is 0. Are they equal? Well, let's see. That's negative 1 equals 1. No, they're not equal. That's false. So we'll eliminate that as a solution. Now let's check x equals 3 pi over 2. Cosine of 3 pi over 2 minus sine of 3 pi over 2 equals 1. Again, does it? We'll ask that question. 0 minus negative 1, is that equal to 1? Well, 0 minus negative 1 is positive 1, and it does equal 1. That is true. Great. So, two of these are actually solutions. X equals 3 pi over 2 and x equals 0, but not x equals pi. That's not a solution. In fact, it's what we call an extraneous solution. It came only from the fact that we squared each side of that equation. So we have two solutions. X is 0, 3 pi over 2. Well, that's all I have for you today. I hope this has been helpful. Until next time, take care.